All right, welcome. Question. I just discovered gum on my floor. That's puzzling. That's disturbing. Let's see if we can get this off. I don't like gum on my floor. I think I may have to eliminate all gum chewing in class because people can't find the trash can. It's like, really? Find the trash can. And all I'm doing right now is just making it worse. We'll take care of that in a minute. All right, video's going to be long enough. Similarity. How do we determine if triangles are similar? Okay, similar triangles, which would make sense because we're talking about triangles. Similar triangles are triangles that have the same shape, not the same size. You can see this. Same shape, not the same size. One bigger, one smaller. Okay? So we have similar triangles. We cross that one off. Right? We'll use the word bank. Similar triangles always have corresponding angles that are congruent. Sorry, lazy, not going to write the word. And corresponding sides that are proportional. That's proportional, not proportional. Good thing this is an English class, right? Proportional, probably didn't even spell that one right. Okay, use that one, proportional. For two angles to be congruent, they must have the same measure. That's what congruent means. For example, look at the triangles and side lengths in triangle ABC and DEF. All right, so if we look at these, since the triangles are similar, they have corresponding angles that are congruent. Okay. And identify pre-image to image. Pre-image, again, read left to right. We want to be in that consistent pattern because that's going to help us down here. Find the angle measures of each angle. Angle A, 77, corresponds to angle D, which is 77. Pause and fill in the rest. You should be able to do that. These triangles also have corresponding sides that are proportional. Did you fill in the rest here? If you do not, pause and do that. Write the ratio for each pair of corresponding side, that should be sides, as a fraction and simplify. Again, we write image over pre-image, image over pre-image. This is why I identified the pre-image and the image. Pick a corresponding side. There's no hypotenuse in this here because we don't have a right angle, although there kind of is, but we don't need to get into that. I just want to pick left to left, right to right, bottom to bottom. So let's start by comparing the bottoms. I want to go image, again, image over pre-image. So 12 over 24. What does 12 over 24 reduce to? That should reduce to 1/2. Now I'm going to go left to left. 8 over 16. What does that reduce to? Yep, you guessed it, 1/2. And then I have 11 over 22, and that also reduces to 1/2. Now, why did I go image over pre-image and set them up this way? Because what do we call this 1/2 now? Now that we've found it, what do we call that? Yes, we call that our scale factor. This means that the ratios of each pair of corresponding sides are equal. The ratio is called the scale factor. And that's exactly what I said. Since the scale factor is 1/2, if we'd have set it the other way, if we'd have reversed it and not cared, we'd have got 2 over 1. And that was not accurate. All right? Since the scale factor is 1/2, that means that the lengths of the triangles DEF are half the size of the side of the lengths of triangle ABC. Go back and double check that. We can say that these figures are by using this little symbol here, and we call it similar to. Again, you've seen this. This is a review. And we can write the triangles are similar. This is my similarity statement right there. Triangle ABC is similar to triangle DEF. That is how I say that. That is a similarity statement. So how do we find missing lengths of similar triangles? Well, we're going to find them just like we found the similar sides of other figures. You can use proportions to find missing side lengths of similar triangles. Let's try it. So we have one triangle here. Again, we're going to find the scale factor. So I got to determine which is the pre-image and which is the image. So PRE over image, so pre-image over image. Then write the side lengths as a ratio and determine the scale factor. Side blank corresponds to side blank. Well, I have to know two of these sides. Which of the two sides do I know? I know the longest side. And scale factor is image over pre-image. So side 36 corresponds to side 24, and both of those side lengths are given. So find the scale factor. So 36 over 24, oops, it's 24, not 27. Right, what you mean, Mr. Wilson? 24, gotta wait for that to go away. 24, all right, so what does this reduce to? What is the greatest common factor that will go into both terms? The greatest common factor that will go into both terms, this gum is really bugging me because I got new carpet, so I think I'm gonna X-nay the gum because this is twice and I'm just a little upset with that. Back at this, 8, divide by 8. Nope, not divide by 8, 8 won't go into 36. 6 will go into both. 12 will go into both. Why? Because I can reduce 4 over 6. So divide by 2 again. So I divided by 6, divide by 2. You could have skipped a step. So that's 3 halves. So the ratio is, the scale factor is 3 halves. All right. So the scale factor is 3 halves. The side lengths of what? The side lengths of QRS, right? QRS. I could have said this differently. I could have said SRQ. I could have said RSQ. However you said it. We said Q, R, and S. So if I went Q, R, and S, I got to do the same thing in the other triangle. R 3 halves times the size of the length of J. That should be a J. K, L. Now I know that Q corresponds to J, R to K, S to L. That's how I know that happens. We'll see that come up again in a little bit. All right. Now, write and solve a proportion to find x. Use the corresponding side length, 21, and start with the ratio of what? What do I want to start with? I want to start with the ratio of 21, excuse me. That should be 21 to x, I believe, because 21 over x, 21 over x. Set the ratio equal to the scale factor of 3 halves. All right, so that's what we're going to do. We're going to use what we know. So we're going to start with 21 over x, because that's my comparison. Large figure to small figure. Got to do the same thing over here. 3 halves. That comparison is large figure to small figure. Now, cross multiply. When you do, you get 3x equals 21 times 2. Now, a lot of you are going to want to multiply 21 times 2, and again in class I'm not showing that. Why? Because I know that I've got to divide by 3, and x is going to be equal to. Why do I want to multiply these two only to go back and reduce? Will 3 go into 2 or will 3 go into 21? 3 will go into 21. 7 times 2 is 14. There. I didn't need a calculator. Next, write and solve a proportion to find y. Use the corresponding side length. What does y correspond with in the other figure? Corresponding side length of 16. Yes, you guessed it. Now, is y the bigger figure or the smaller figure? Because my scale factor, which is what I'm going to start with, goes from big figure to small figure, image to pre-image. So is y in the image or pre-image? Y is in the image, so this ratio is going to be y over 16, not 16 over y. All right? Now, when I solve this, I should cross multiply again. 2y equals 16 times 3. Again, I did not multiply them. I did not multiply them. Why? Because I'm going to divide by 2. Y is equal to, now let's say you did multiply them. You're going to get y is equal to, and bear with me here, 18, 3, 4. You're going to say 2y is equal to 48. Now that's not too bad. I can take half of 48. But why do I want to even mess with that big number when I can go here? 8 times 3 is 24. Okay? I don't even need a calculator. All right? So there's that one. All right, now, that's how we set up proportions using the triangles, all right? If we know they're similar. How do we determine if triangles are similar? How am I going to determine if two triangles are similar? That's the other part of this. So if you need to pause and take a minute, go ahead. But I know the notes and the video is going to be a little lengthy today, but I'm going to cover these. The coverage of these shouldn't take too long. Testing for triangle similarity. To show that two triangles are similar, you can show that all corresponding angles are congruent and all corresponding side lengths are proportional. We have special conditions that have to be met. Right here, angle, similarity. This is one way to determine that figures are similar. If two triangles have two pairs of corresponding angles that are congruent, then the triangles are similar. Here it's showing you, okay? In the pre-image and the image, I have O congruent to R, N congruent to Q. Are the figures similar? Well, look at MNO and PQR. There are two pairs of corresponding angles that are congruent. So O is congruent to the measure of angle R. Don't just put R, right? You put the measure of angle R. And the measure of angle N is congruent to the measure of angle Q. So triangle, and this is how you have the liberty. You can start wherever you want, okay? You can start at M. So triangle MNO, and if I said MNO, I have to do the same thing in the other figure. So I have to start with what? P, not R. I don't want shapes, no eraser. P, Q, R. That way I know M corresponds to P, N to Q, O to R. That's how I know that, right? This is triangle similarity. It gives me a tip. And the tip is not in your notes. I don't know why it's not there. If you know the two pairs of corresponding angles are, well, I'm going to skip the tip then, because if the tip's not there. Basically, what it does is it talks about, hey, if I know that these two angles are congruent, then M has to be congruent to P. Why? Because all three angles in a triangle add up to 180 degrees. These two plus that one would have to be 180 degrees. It would be the same over there. That's the tip. All right? Side angle side similarity. So here's the next one, side angle side. If two triangles have two pairs of corresponding proportional sides and the corresponding angles between those sides are congruent, okay? It has to be in between. That's a huge thing. Has to be in between. Notice X is in between my two corresponding sides. 12 corresponds to 6, 26 corresponds to 13. X and U are in between those two sides. There are two pairs of corresponding proportional sides. How do I know that? Well, compare. We have pre-image to image, and we're just going to check that real quick. We're just going to check and verify that those are the same. Again, image over pre-image. So 12 over 6, is that equal to 26 over 13? I'm having a tough time writing today. Go figure, it's Friday. Tough time on Friday, tough time on Monday. 26 over 13. Are these two equal to each other? Yes, they are. So the two sides are proportional to one another. The angle is in between those two sides, and since the angle is in between those two sides, the measure of angle U corresponds with the measure of angle X. So one triangle is similar to the other, and I can say this any way I want. Okay? I'm going to start at S, T, and U just because that's kind of STU. Now, if I said STU, what do I have to say in the other triangle? V, W, X. S corresponds to V, T to W, U to X. That's how I know that that works. There's your side angle side similarity. And the next one, side similarity. Well, gee, it shouldn't take a rocket scientist to figure out that we're comparing congruent sides, corresponding sides. So that's how I'm going to compare that. So now, how do we do this? We do this pretty easy. You can look at this and see that we have a pre-image and an image, and I'm going to set up a ratio for all of those corresponding sides. Start with the biggest one, 16 over 12. I'm going to say that that is equal to 12 over 9. And that must be equal to the last comparison, which was 8 over 6. Do all of these simplify to be the same? Are they all the same? Will they all reduce to be the same? Because if they are, then the figures are similar. So since the ratio of the corresponding sides here, flip over my notes because I'm a page behind. Since the corresponding ratio, these all equals 4/3, okay, which is a big check. 4/3, that means all three pairs of corresponding sides are proportional. I think I spelled that one right. They're all proportional. So what does that mean? That means these triangles are similar. So I'm going to say triangle CDE is congruent to FGH. All right? And lastly here, and I know I'm blasting through this, but what are the three methods for determining two triangles are similar? What did we start with? We started with angle. What's a little squiggly mean? Yeah, similarity. We started with angle, what was the second one? The second one was side angle side. side angle side similarity, SAA. Come on, Mr. Wilson, get it right here. We're going to erase. We're going to start with side angle side similarity. And what was the last one? The last one was side 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 similarity. Right? That's to figures are similar. Now, we're going to backtrack a little bit, and we're going to ask you, what are the 5 methods for determining that two triangles are congruent? So this is a little bit different. Can you name them? Pause them and see if you can get them. All right? I'm going to play with the gum here a little bit more and see if I can get that off the floor. While you do that, paper kind of works. At least students could chew Freedent, you know? Freedent doesn't stick to most dental work, and it probably wouldn't stick to my floor either. But it's sticking to the floor. And I got another spot over here somewhere. Maybe the custodians went ahead and picked it up. Okay? Your 5 methods for determining that two triangles are congruent are side, 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 angle, side, angle. And we didn't talk about the other 2 a lot. We did mention it once. We have angle, congruence, okay, or angle, side, rather. And we have hypotenuse, leg, which we don't talk about hypotenuse, leg a whole lot. So anyway, there's your notes for Friday.